Okay, let's take a look at the problem that I have put on the screen here. This diode problem, and instead of using the ideal diode model, let's use the constant voltage drop model. And I've just put the constant voltage drop model here for our reference. So in the reverse bias, that is when the diode voltage is less than 0.7, a diode can be replaced by just an open circuit. And in the forward bias, as shown here, the diode will be replaced by a 0.7 volt source, as shown here. So, right, so that's the constant voltage drop model. So let's try to solve the problem for that. Now, if you look at this circuit, and if you say that the diode is reverse biased, it's a fairly trivial problem, right? Because if the diode is reverse biased, there is no current flowing through this. Therefore, the current is zero and the voltage drop across this R1 is zero. So I'll leave you to look at the reverse bias, and let's just focus on the forward bias problem. So in the forward bias, I can replace this diode with a voltage source of 0.7 volts, right? So this voltage source is 0.7 volts. Now, if there is a current I flowing through the circuit at that time, and the current is going to flow in the forward direction, right? So, the what is the current? How would you calculate that? You can calculate that by writing the KCL equations, right? So this is plus minus, and there's a voltage drop here like this, and there's a voltage drop here plus minus. This end of the resistor is the more positive end. Why? Because the current is flowing through the resistor like this, from the positive end to the negative end. Okay, so let's try to find out the current. So we write V1, that's the voltage across this 5 volts, and then we have a voltage drop across here, so we can write minus 0.7 volts minus IR1 will be equal to 0, right? That's the Kirchhoff's voltage law across this. And this gives us I equal to V1 minus 0.7 over R1. And if you substitute the values of V1, which is 5 volts, and R1, which is 10 kilo ohms, you get 4.3 milliamperes. Now, we have got in this case a positive current, right? And this diode that is here is going to be forward biased as long as this current is positive. And what is the condition for this current to be positive? The equation for the current is given here. When will the current be positive? We can write that equation, right? Uh, so we can write the diode is forward biased. When is it forward biased? It is forward biased when I is greater than 0. And this implies V1 minus 0.7 is greater than 0. And that gives us the condition for forward bias, which is V1 is greater than 0.7 volts. So we get forward bias when V1 is greater than 0.7 volts, and we get reverse bias when V1 is less than 0.7 volts.